How's it going? It's getting started here real soon, just setting everything up. Make sure people who want to watch and come in or ask questions are here. How are y'all doing today? Cool. Oh, cool. You're studying networking at school? That's awesome. I don't know if I had the opportunity to do that. I pretty much learned everything in high school through like guides online, I think. Yeah. I don't know if you ever seen, I think Beej's network programming, socket programming website. I think it's still around. Beej's guide. Yeah, I think it's Beej's guide to network programming. Yeah, something like that. This was a great site back when I was in high school, I think, for learning how to do socket programming. A little detailed, might be more than you need. And I don't know if you're going for stuff that low level, but it's a great introduction. It's about to be that time here. So let's get started. Hopefully everybody who wanted to watch or at least ask questions are here. Not too. I know I understand it's pretty late on the East Coast out there, so I will have this on YouTube later. So yeah, hopefully this time I'm gonna keep it under an hour. Hopefully we can cover all the things I want to cover for this, but we'll see. Anyway, yeah. Okay, let's get started here. I think as I discussed last time, we have this issue basically where whenever we send off a packet with our input, what we do is, so I'm just going to bring this down here so we can talk about things. So when we send off a packet, basically, say like your player 1 is at frame number 5, player 2 is at frame number 5. So we're in synchronization right now. It's fine, whatever. Okay. So you need to record input and then update for frame 6. So let's say on P1 side, what happens? So we got input for frame 6, update. So got frame 6. We also recorded input for frame 6 from input polling on the device, on your PC or whatever, and then updated or ran the 6 update of the game simulation, right? So this is great. So we're updated, but what happens on P side, player 2 side? Well, this is a scenario we're running into. So on P2 side, didn't get input for frame 6. Well, this is fine. So put it this way. So basically, what had already happened is, let me restate this a little bit. Okay, so let's just assume that P2 has already updated frame 6, right? Now they need to update to frame 7, or the 7th update of the game, right? So let me double check this thinking. Okay. I just want to make this clear so it's not confusing what's happening here. It's one of those off by 1 errors you can run into a lot. But okay, let's assume P2 it's still at frame 5. Okay, I'm going to sort this out here in a second. So at frame 5, so we've already done 5 updates. Uh, we've done 5 updates. Record input for frame 6 and sent input for frame 6, but didn't receive input for frame 6. So in this is not scenario, what's happened is both players were at frame 5 at the start of the game loop. Both sides recorded input for frame 6, sent input frame 6, but on the P1 side they received the input for frame 6, but on P2 side they didn't receive it because of packet loss. So what's happening now, what we're going to keep seeing here is, now that P1 side is at frame 6, say it's the next update or next loop. On P1 side, we're now at frame 7. Let's say frame 7. Oops, sorry, we're at frame 6. Sorry. And now we record input for frame 7, and we are sending frame 7's input to P2. This is great. Then the problem is we can't update because P2 is still stuck on frame number 5. So it's still sending frame number 6 input because it recorded frame 6 input, right? But it still needs to get to frame 6. Don't have frame 6's input. Sorry. Yeah, frame 7's input. So stopped. And on P2 side, we're still at frame 5, right? And we're trying to update, but we don't have input because the input we received from player number 1. So we received input, but it's for frame 6. Need frame. Sorry. Let me double check this real quick. Oh yeah. So we received it, but it's for frame 7 because P2's already updated frame 6 and recorded frame 7's input because we're only sending one input at a time right now. So we received, but it's for frame 7, so can't update because need frame 6's input. Okay, that's the basic idea. We're stuck because one client gets ahead by a frame and it's only sending that frame's input, and the other client's behind and needs the previous frame's input to update to get to that point. So we're desynced throughout. So they're stuck ahead, and we're never going to receive the input for frame 6 here on P2's side because player number 1 is stuck was ahead. It's already ready to update frame number 7, and he recorded frame number 7's input and it's sending that only. So what we need to do is we need to send old inputs to the other player so that they can catch up. So the way we're going to do this is we're going to implement a history of inputs, and we're going to send a history instead of a single input each packet. One thing we could do is we could do the history and have, say, one side request the old input, but we have to entail the latency, the round trip time of sending a request and receiving the input. So we're going to get in this like weird lock situation where it's stopping, requesting input, waiting, go to the next one. It's going to give you vice versa, and you're not going to maintain a solid frame rate. Okay. There's one other issue we'll get to here in a second, but let's just deal with the whole thing of having old inputs when the packet loss is involved. Okay. Yeah, too slow. Call me killer. Okay. So our agenda today, I'm just going to put this in another scratch pad. Okay. So what we're going to do today is we need to keep a history of inputs we already processed, and we'll send all these inputs to the we'll send not all of them, but we'll send a good number of them over to the other player at once. Yep. And then in our network message, I think I called a package in the code. Let's say message for now. We'll send the history. For each packet, we're going to send like a number of inputs from our input history. And we're going to have to store off those inputs because there's potential that we'll receive future inputs, right? And we want to record them in case in the future when the other player sends more packets, in case those packets are also lost. Okay. Okay, so let's look at what we have here in the code now. Let's move this here and make it easier. Okay, you should be seeing the code. Oh, you're not seeing the dynamic stuff. Give me a second here. I forgot to turn that on. Okay, so you should be able to see the code here, right? Okay. So previously, when we record and send inputs, we're only sending the current one. We created this structure here called network input package. Right now, it only includes the input command, which is just an integer, which indicates the which controller inputs are on right now, and then the frame count. This is how many times we've updated the game simulation. This is not enough. We're going to have to change the input command here to just an array of input commands. And then when we actually update our network, either a host or client side code, we send that off. We send the current input. This is a network package here, right? We're just initializing it. We send the current input for our player side, and then we send the indicated that it's for the next frame, right? Okay. So that's one more thing I want to check. Hold on. Yeah. Okay, yeah, right now we're just recording off the input here. Okay. Is there any questions? So just let me double check things here. Probably should move this over. You know what? I'm just going to move this here so it's easier for me to see the chat window. Okay. Okay, so during our network update, let's see what our flow is right now. Okay, just a review. We record our inputs into this net buffer here when we have a gamepad set up. And then we send off the input through these calls to tick network host and tick network client, depending on which side you're on. And we're going to see if we have the input for the next update just by looping through all the network history inputs we got. These are just the inputs we got from the network. If we have the frame count, we'll why did I set this here? Is this an error? We go through all the network history. Hold on real quick. Well, was this a bug in the code? I didn't even notice that before. This should have been set to true. That's definitely a bug. I don't know if anybody pointed that out before. But basically, yeah, we're going to loop through all the network history. If we have the frame count we need, we'll indicate that we received the network input. Yeah. Oops, error there. Oops. Let's see what happens with that. We might get lucky now because that might have been actually a bug in the code. Oh, nothing's updating. That's fine. Hold on real quick. Let me minimize this. I should have these up here. And you probably can see it says we received net input for frame 2 here, and it says we received net input for frame 4. So one side is 2 frames ahead, the other, and we're desynchronized at this point. Okay, that's just a quick check. Oh, sorry. I see what I did here. this was an out variable, right? So this function would actually set that variable to true. Sorry, so that this is false. Um, I'm kind of curious. I'm trying to remember exactly what I was trying to do here. Okay. So we're just checking to see if the latest input we received was equal to any of the things in the history already. Okay, that's basically what I was doing there. It's kind of unclear here what this is. I should have left better comments. So basically, once we know that the latest input we got here was new input, it was for the next frame. What we did here was we recorded off in the network history, and then we increment the input history index. Yeah. Anyway, this is all going to change with the buffer stuff. So let's implement the network history buffer. Okay. Great. So let's go up here where do we declare this stuff. So right now this buffer is just used for the network history we've received. We received this input history for the network. This is going to kind of go away. We're going to replace it with this a general history buffer. And I want that for both players so that we know what to send and we know what the inputs are for the player on the other side of the network too. So for now, let's just assume the size of this buffer is going to be, well, let's just change all this anyway. For now, let's call it replay. Let's not call it replay history. Let's call it. I give it a good name here, so I'm gonna rename this. Okay. So I'm just gonna rename that. Make sure it builds. Oh, really? Oh, that's why. Okay, that's fine. Okay, it builds. So anyway, let's call it input history size. And actually, if we think about it, like how much network history, if we want to record the entire match, let's say our match is 3 minutes long, right? And it runs at 60 frames per second. Well, it's just 60 seconds in a minute, and then times 60 frames a second. What we need is 10,800 integers, right? And each integer is what, 4 bytes? So it's only going to be about 43K. It's not too bad, right? So for now, let's just do that. Let's make it equal to, well, we don't actually, we just want to record the number of integers here. So 60 seconds, 3 times 60 seconds times 60 frames. And then, actually I'm gonna, what's this here? And we have a new buffer here. And we need two. We need one for player one for player two. So we need to make this the size of 2, and let's say input history. Okay. And we need to make sure this is right. Okay. Okay, cool. So this is basically the goal here is we're going to record off the input history locally here, and we'll send off a chunk of it in each packet. Okay. So for now, we need to go down here and record it. So where's our input polling? Okay. Um, okay. Mm, okay. I'm just gonna say that for now. Okay. Let me get a so we get this coffee here. All right. And what we call it? Well, not input history, right? And this is going to indicate which side we are. So we're not the opponent's side. So basically, yeah. This just indicates index 0, 1, depending on whether or not we're the host or the client. And right now, the host is player 1, client is player 2, I believe. But anyway, give me a second here. Oh, sorry, I messed up here. This doesn't need to be here. Oops. So net input buffer gets this. It sets at 0. This is when we're recording input locally, I think. Yeah, up, down, left, right. Okay, we're going to record off our inputs here. Oof. This is network history buffer. I'm trying to remember what this is for up here. Oh, yeah, this is, sorry. Yeah, what I was doing here, okay, I got to fix this. I believe what I was doing here was using the input for the last frame. Yeah, so I needed to have at least a 1 frame input delay so that the two clients wouldn't get locked, because you at least need the next frame's input to update. Well, sorry, you need the current frame's input to update. You have your own frame, but you don't have the other, so you can't pull, they can't pull. Anyway, for now, let's just say there's 1 frame input delay because we need it for network synchronization. Okay. What is that? What I called it? I called it. Oh, yeah. I need to. Okay, this is right. So we need the frame count. Where's the frame count? The frame count. Okay, hold on a second. Where's our frame count? Oh, it's the simulation state. Okay. What do we call it? Game state? Okay. Okay, when you get the... That's right. So we have the current frame of the game, and we're going to set the input here. We might change this up here in a bit to be put everything that's related closer together, but for now, that's what we're going to do. One thing I'm thinking is we actually want to record this off almost immediately because we want to send... Okay. Got it. I know what I need to do. We need to record off the input we pulled almost immediately because we're going to send this over the network. We want to send it as soon as possible to reduce any form of latency. So we don't want to unnecessarily introduce, say, an extra frame of lag in any of the data we need to send over the network, right? Because it's going to incur a penalty on the other side. So we're going to pull for inputs, and then we're going to immediately record it into our input history. What's the problem here? Oh. We actually don't need this whole thing. I don't actually need to record an entire network package. I just need an integer because we're only recording the inputs. We're going to know what frame it is just by the index of this buffer. So that's fine. What's it complaining about here? This is just indicating that the buffer isn't big enough to hold all potential bytes. So we can always do a check here. I don't have an assert set up, but just to get rid of the warning. So we're going to say if the frame count is less than hold on. Give me a second. What do I call that? Input history size. It's not the safest necessarily thing to do, but I just want to get rid of the warning. Is they still going to complain? It's going to complain about buffer overrun. Okay, let's just kind of ignore that error for now. Anyway. But yeah, this is something if you're taking security seriously, you need to look at. But this newer version of Visual Studio, I'm like kind of surprised it actually indicate that. I digress. I'm gonna move on here. Okay, but actually here, the thing is, we're gonna assume one frame input delay. I'm gonna talk about this here in a bit, but for now, what we're recording. I did talk about it. It's not that complicated. It's just basically copying bytes over. But we'll get back to that error bus. Okay. I'll talk about this in a bit, but we need to include a network input delay. I'll talk about why this is needed here in a second. We're going to set it to 1 at this moment. And we're going to use this variable, well, this constant, to indicate where we need to record our local inputs. So this is going to be the offset of the current frame count plus input delay. Right now it's 1. So before we say do the first game simulation, we're going to pull inputs, and we're going to record that input for frame number 1 and not for frame number 0. Well, second frame, not the first frame. Index 0, index 1 is once with the delay, index 0 if we didn't have the delay, but it's going to be recorded at index 1 in this case. And on the next frame, next frame, next frame. Current frame, well, the frame we intend to update. Well, yeah. Yeah, this is not a stream on security and safety. I mean, we're working basically in pure C, so if you wanted a safe language, you might want to work in Rust. If I went over all the things that, well, here it's generally fine because we know input history. Input history could be changed, but yeah. Anyway. Sorry. Maybe it's going to get rid of that if I do this. Okay. That fixed the error. Sometimes you just add or subtract 1. Yeah, actually, frame count needs to be... Oh, sorry. It needs to be this, actually, not 1. It needs to be minus network input delay. Because we don't want to add... Because if we were at, say, index number, input history size minus 1 plus network input delay, it's going to be a buffer overrun. Anyway. I digress. That should fix it. Okay, so we've recorded the input polling. What we're saying we're going to do next? Keep history inputs. So we need to send this input over the network. So what do we want to do? Do we want to send the inputs first, or we want to prepare recording the opponent's inputs in our network history? There's a few different tricky bits here, but I'll talk about them in a second. Okay, let's prepare to send them, and then we'll do some logging and see what we get, right? Okay. So we need to update these functions to take a buffer instead of a single input. Right now we're passing this network package thing. Here's actually a decision we should do. Do we want to just like pass in the network history pointer, the pointer to the array, and then do all the stuff on the network side, or do we want to do the actual memory stuff on the local side? You could do either or. I like to keep the code that's all doing the same thing close together, but we have this nice abstraction already set up with the network input packet, so I kind of just want to do it here locally when we prepare this network input packet. So let's just do it right above here. Okay. Just keep things close together, nice and simple, so it's clear what we're doing. Okay. So first thing we need to do is we need to change this structure to take more inputs instead of a single one. Okay. So first, let's make a new constant. I'll just say for now. Net packet input history size. This is very long, and we're going to change. Sorry. So we're going to add this network history. Oh, I didn't set this. How big is our packet going to be? I'm going to be kind of arbitrary now and just say 10. It may be big enough, maybe too big. That's going to be 10 times 4 integers, so 40 bytes for the input history. And we're going to get rid of this in command. Obviously, we're going to get compile errors, but I'm just doing this so I can quickly find what we need to update. Yeah. So let's build so I can get the errors and jump to the things really quick. Okay. So this we have this code for finding input for the next game simulation. We're not going to pull things directly from this input package anymore. We'll deal with that here in a second. That's when we're going to be recording off the input history from the other player. So for now, I'm just going to comment this out because we're actually probably not going to use this code at all. Okay. We just want to test sending and receiving that input history. We get some error about into da 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 da. So yeah. So right now we're sending off the network. We're just constructing the package like here, right? So we need to construct this in a different way. Okay. What we need to do is we need to loop over the last 10 inputs and send them. Okay. So for we're gonna index equals 0. I'm just gonna use I because generally I want to have full names for variables, but in loops like this, it's generally fine. When they get bigger and more complex, we can change I, or if you have a J, for example, if you're doing like a loop, looping through a 2D array, then you probably want to change the variable names just because I and J look very similar. It's easy to make mistakes there. Anyway, that's another digression. So we want to loop through, what was it, the net packet. Man, I really need visual assist here because I don't know net packet input history size. So actually, before I do anything else, I'm going to indicate what we're going to do here in plain English. So what we're doing is fill the network packages input history with our local input with our local input. Okay. So we need to start 10 frames ago and copy each input over, right? If we're at frame 0, whatever, we just fill it with zeros. Okay, that's the easiest part. Obviously, we don't have input for -5 frame or whatever. So for now, I'll make an error here and fix it. So the general idea is well, we're going to say subtract the network input history size, right? From the naive, simple math here is game state minus frame count. Obviously, we can't index this directly like this, but it's just going to be a quick brainstorming session I'm going to do here. Okay, and what was our history called? Network input history. Okay. Obviously, we're going to get negative indexes here if I do this, and it doesn't take into account input delay, right? So I'm actually not going to zero out input that's older in this package because we're not even going to read it. So it's not even important. If you're worried about it, you can zero out, but if you really don't need to worry about it for example code like this. Anyway, so let's just do this. Let's do let's just call it input index. We're actually going to calculate the index like this. So we're going to use it multiple times. So that's the basic idea. It's going to be the current frame count minus the input history size. So the input history size is 1. If you're at frame 0, obviously it's going to be -1, so you're going to add 1 to that to get the current size. If you're at frame 2, you subtract 1. You don't have you're at frame 2, you subtract 1. It's not actually 1, right? You need to send 2. But then also when you consider input delay. So what was the input delay constant we had here? Need more coffee. Yep, okay. So we need to consider network input delay in this in this equation. Well, sounds too fancy. It's a simple formula. Okay, so this is kind of the basic idea. Let's think through this. Okay, we have frame number. Let me copy paste this because I like to think through these problems before I jump in. So let me zoom in here. Oh, can I not zoom in here? Okay. Well, let's jump over to Scratchpad, not in our planning docs. Okay. Okay, so we got our current frame count. Let's start at the very base case. Assuming we're at frame number 0, and we have a network history size of 10, our start index, well, this is the input index, this is going to be equal to negative 10 plus 1, negative 9 plus negative 8, is that right? 0, negative 10, 9, 8. Okay, so obviously oops. So that's going to be our start index, and we need to add the current. We can do it 2 different ways. We can do start index and then add I here. But obviously we're calculating it every frame, so it's not really needed. So sometimes I like to do things like this just to make code more clear. So we don't need to actually calculate that each time. I think the compiler does a good job of getting rid of this stuff, but yeah. Okay, so let's say input start index. Okay. Anyway, we're gonna come back here. So we're gonna loop through this. How many times? We need net input history times, right? And then we could do this too. say input index, something like that, equals plus I, and then we could do something like we could do some more optimizations here if you really wanted to, but then we only copy the things for indexes that are greater or equal to 0, right? Sorry. Okay, we need a new network input package. Let's just call it toSend package net package. Okay. And wasn't updating there. And the input history at I. So we're going from 0 to network input history size. This will be 9 for the final index, which is going to be fine here. We're not recording off anything for the for any indices that are less than 0, things that are actually older than when the game started. Okay, what's going on here? Oh, huh? Oop, that's the wrong. It needs to be input history. That's what's going on there. Okay. Okay. What's going on here? Oh. Is that not unsigned in? Int. Got it. Oh, whoops. I need to send off the input for our local side. You know what? I'm gonna go up to here real quick. And okay, so I don't have to do the negative. It's kind of confusing to think about things in negatives, so okay, where were we? Okay, yeah. So our local side, we store that off in this buffer. Are we getting? Give me a second here, make sure everything's okay. Cool. So we store this off in the buffer here, and I just want to do a sanity check here. I'm going to think about the bounds, right? Going back to our scratch pad. So we know the input index. Oh, this is actually what it's going to equal to. It's going to be equal to this plus I. Okay. So our current frame is going to be at the very end of that buffer, right? So when I is equal to minus 1, it's going to be equal to 9, right? Okay, let's do all the math here, see if it makes sense. So let's just do this start index. So we don't have to think about this many times. So we got that again. Frame count was 0 minus 10 plus 1 is 9 plus, so equals -8. So if we just start index plus I at the very end when it's equal to 9, we get 1. And this makes sense, right? If we had no input delay, well, hold on, put this here. If we had no network input delay, say it was 0, then the final input in that buffer would be 0 for frame number 0. But that's not what we're sending. We're sending a frame number 1 in this case. And that makes sense because we're adding an additional input delay locally too. So the input we recorded is for frame number 1 is the next frame. And if we adjust this variable to say 2 frames, then it's going to be for frame number 2 or the second frame. Wait, let's double check that sanity. It's so index frame number 1 is going to be the second frame. It's just because we index by 0, starting at 0. Okay. So this seems to follow a sanity check, right? Seems about right, but we forgot something. We need to record the actual current frame, or what that final input in that buffer, what frame is that designated to or intended for. Okay. Oops, I need to cut this off. So let's say, let's call this okay, and then well, that's not what I want to do. Oh. Frame count, right? Okay, just checking. So frame count is going to be equal to our current frame count here, plus network input delay. Just a quick sanity check. We want to send the future input when there's input delay, or indicate it's for future frames we're not actually at yet. Okay, so that's prepared, and we can just send it over the network like this. Okay, so everything should just work as before. When we send input message to host, all we're doing is we're creating a buffer the size of this input package. We're not doing anything. We're not looking at the internals of the structure at all. It's just sending raw data. Okay, which is great. We don't have to worry about all that in the network side. So our network code should just kind of work still. So I think that was a generally good decision to prepare it all the way over here and not on the network side. Okay, because I kind of want the network to be more low level and agnostic in terms of our gameplay code. Okay, so we want to see if that works correctly. So we're going to send over, you know what? I'm going to do one more thing. This is just for debug purposes. When we don't have input for these frames, for say like negative indice values, let's just fill it with like a sentinel value so that we can know that we are we're getting the right data. Okay, so these are unsigned integer values. So I forgot what is the max unsigned value. Just give me a second here. I should have a browser here. Let's C++ max unsigned value int. I always forget what that is. There should be a variable. Now they're giving me Japanese because I'm in Japan, but int max. Oh, there it is. Okay. So we're going to assign that. Or we could just do this. It's fine. So this sentinel value, is that the right sentinel? Always start as a sentinel value. Okay, sorry. I can't spell. Anyway, okay, so we're going to log all that stuff to see if it's working. Is there any questions about this stuff? Any of it confusing? Okay. So we handled preparing, we handled sending. Sending wasn't any additional work. Oh, we do need to do this instead of constructing a new package here. Okay. sorry, where's that code we commented out? That's down here. Okay, find input for the next game simulation frame. Here it's just going to look through and see if it had input, but actually this code is needed to change because we now have an input history. We can look at old input to see if we can update. Okay. I'm gonna change this a bit, but how do we want to do this? Really? Oh, okay. We're gonna get rid of this buffer. We don't really need it anymore. It was only recording off the single inputs we were getting from the network, but we're gonna record that off in our shared input history. So eventually we're gonna replace it with that. But for now, I just want to do with logging. So let me comment this stuff out for now. And whenever we receive input, I'm just going to dump the entire history just so we can see if it's working. Okay, I'm not going to do that. Yeah, I just want to dump this stuff. I'm just going to comment this out for now, and I'm just going to dump this stuff out. So we're going to loop through I is less than, what was it? I could not use raw C++ or C arrays here. I could just use vectors, but for now, I'm just trying to keep it simple. So if you're thinking about safety. Anyway, let's do this. Let's just log the let's log the input and which frame it's for. Okay. So the input is D, frame is that, so we need to do frame count minus input history size, right? +1, is that right? So when this is equals to, sorry, well, actually means plus I, right? So so let's say the frame count is for frame number 10 or number 11 or whatever you want to do. 10 minus temperature size will be 10. So that the first index will be 0. But we'll get the index number 9 with this. That won't be correct, so we need to add 1. Okay, that's right. Alrighty, let's just add 1 at the end. Okay, is this going to work for us? Okay. Let's build, see if we got something here. By the way, if you have any questions, feel free to ask. A lot of stuff is in my head, so, and only in my head. Okay, let's launch the game. Oops. Move things over here real quick. Get these logs popping up. Where are they? Okay, let's run the game. Did we crash? What's going on? Oh. So it looks like we are receiving input. Let's kill the games and look at our history, our log real quick. So, are y'all seeing this? Yeah. Okay. Oops. I know the chat's kind of covering it, but this is all we can. So on the player one side, we can see we've been receiving these inputs, right? Let's get to the very start, see what happened. This is pretty much exactly what we predicted, right? We received input for frame number 1. The final input in that buffer was, did we not copy the frame over? Yeah, we're getting a weird value here, right? What did I do? Wait, what did I mess up? Oops. I did not put the actual input. Okay, I'll fix that. Give me a second. We do make mistakes over here sometimes. Okay, it needs to be I. Okay, let's rebuild that, redo everything. Rerun the game. These are like same values now, right? So let's stop the games. Look at the history. So looks pretty sane. So input number 1, see if those are sentinel values, right? I'm trying to get up very high up. We have the old log. Okay, here we go. This is initializing the game. Okay, and we received input for frame number 1. Oh, you know what? I forgot to. I need to print unsigned values. Sorry, I forgot it's unsigned values. So, is it U? Yeah, it's been a long time. So U is for unsigned. Sorry about that. Let's do that one more time. You know, I need some sugar. I'll be right back. Got to get some quick brain food here. Okay. Just some Reese's. Very hard to get here in Japan. You have to get them shipped from overseas or get access to like one of the military bases or something. Get some friends out there. Anyway. Let's redo this. Rerun our game. Okay. Stop it. Let's look, see if things look sane now. That's weird. We shouldn't be getting negative values. What did I mess up here? Huh. Sorry about that. Give me a second here. This would be unsigned decimal integer. Huh. Yeah, I wonder why I'm getting printing negative values. Let's try this one more time. I think this is very weird. The U should indicate unsigned integer. Oh, we're not getting any updates on this side. Oh. Weird. I might have to restart this. Okay, there we go. Okay. Looks good. Though I do kind of want to print binary so we can see directly what inputs are being enabled. So, oops, what is it? I always forget about this. Or, yeah. Binary format? No, there's not such thing. Don't worry about it. Anyway, moving on. It seems to be working like we expect, I think. Do a quick sanity check here. So we received net input for net input for frame number 2. The final input is indicated for frame number 2. It's input 0. The frame number 1 is also 0. These values are not sane because they're saying these are sentinel values, right? They're just the largest integer. Frame number 0, I think we did record something. Sorry. Oh, right, we didn't initialize our buffer, did we? We're gonna have to initialize that, or we might end up with desynchronization. This needs to be set to 0. So let's do that real quick. Oops. Any questions on like what we're doing so far? If we don't initialize this as 0, what is it? I always forget the syntax to memset. Is it? It's also mem0. I forget if there's one. Sorry. Actually, I wonder if ArrayLib has memory memset. Destination site, destination value count. And we're in Japanese again. Okay. Yeah, destination. Okay. Yeah, I'm just gonna zero this out. The destination is input history. I forget if size of. Does size of give us bytes or just gives us the count of the thing? I think this is right. Let's just do. Not necessarily the safest thing to do, but when you make this 0, right? Because it's like count. Hold on. Is it bytes? It's bytes, right? Well, let's hopefully it won't crash. Oops, there's an error there. Usually I'll use something like a mem0 or something, utility function from our engine library or something, so that it's more platform and agnostic. But okay. Alrighty, let's close our game. See if everything looks good. Oops. Okay. Okay, now it looks good. At frame number 0, we are getting the value 0. Okay. And it does look like we're getting stuck at frame number 2 here because we're not really updating past that point. Okay. Let's minimize this and look at this too. Other player side, we should see something very similar, right? These are all the negative negative indices, which are just using the sentinel value, and then above that we get 0 because we haven't input anything yet. Seems to be good. So the logging indicates that everything's a-okay. So the next steps is we've recorded our local input. We've sent the input in the buffer over to the other player. We received that input, and we're able to see that we are getting what we expect. So the next steps are to actually apply that input to our local memory, our input buffer locally, and we also need to read that input for the game simulation. I'm going to get to that in a second. There's a few tricky things there. I'm going to take a short break, but I'll be right back. Okay, I'm back. Any questions about the previous stuff? If not, I'm going to move on. It's already been about an hour here and 15 minutes, but I'll keep going for now so we can finish up this packet loss stuff. So we could naively just take the inputs we had received and just copy it over to our local input buffer, the input history variable we had here. But, the issue with packet loss is we might get all these future inputs, but we might still not have the inputs we need to do our game simulation so far in the future. Or we might get it out of order, right? So what we need to do is we need to record off which. So how can I state this? So we need to record off like the latest frame we've got from them without any gaps, right? So say the latest frame input we got was frame number 10. We'd receive packets from them that has at the very end of the buffer frame number 11. Then we can record that off from frame number 11 all the way plus 10 to 21 or whatever. Then we can keep moving on from that point. But if we receive something, say like frame number, that was for frame number, the end of the buffer was frame number 13. Well, we have that gap between 11 and 13 we need to fill, and we can't update because once we reach frame number 13, we can't move forward because we don't have the input for that. So that's something we need to actually handle. We need to have some way to deal with that case. So Okay, so previously the way we had dealt with the network input stuff was like this here and this stuff here. Here it is logging. Um, so for now I'm just going to disable the logging because we see that it works. If we need it enabled again, I'll come back here. We have this network input history buffer. I'm just going to get rid of this because we don't need it anymore. Yeah, and we don't need any of this actually. So I'm just going to go through here and delete each thing at once. So first thing we need to think about is finding the input for the next frame. How do we know that we have input for the next frame? Well, basically it's going to be, is the latest frame we got from the other opponent, the one we've indicated is the latest frame, is that the current frame that we need to update or in the future? So we need a latest frame value, right? So I'm going to add a new variable here, int latest network frame. I'm going to start at 0. Actually, it can't be 0 because we haven't received it yet. We might have to get back to this. This is something I'm thinking about. Okay, but this okay. So where was that logging we did here? So we looped this network history. This is the logging. I'm going to undo this real quick. I'm just going to disable the logging for now. And what we need to do is we need to record the latest frame. So we need to convert the index to the frame. It's the easiest way to deal with it. So before we do all this, we're going to do start frame. It's going to be the frame count minus history size plus, we don't need the offset here, this plus 1. Oops. Does that make sense? It's very similar to what we did up there, up in this code previously. Yeah, something similar to that, but we're actually converting back to frames. So say they send us frame number 10. We subtracted 10, we got 0. Let's double check that. Let's start at frame number 1. The inputs for frame number 1. History size is 1. That gives us 0. Plus 1 will be 1. So that's the right thing, right? Instead of that, we begin with 10. Frame count is 10 minus 10. So it'd be index 1 through 10, right? Yeah, because the size of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. It doesn't include 0. That's what I mean. Awesome. So we have the start frame. Let's say start frame plus 1, not 1, plus I. If start frame plus I, let's just say int constant check frame equals, let's say if check frame is greater than the latest, what was it? Go back up here. I need a kind of a scratch pad for these variables. Where would it go? Latest network frame. Oops. If check frame is greater than latest network frame, then we're going to do can't be just be. It has to be. The check frame has to be the latest network frame plus 1. I'm going to talk about this here in a second. Because we absolutely need to have the next frame for us to stay synchronized. This doesn't change with the rollbacks, actually. Well, kind of. We'll get to it. Anyway. And then we'll just increment it. We could just assign it, but not check frame, sorry. We'll just increment it. Okay. Okay. So we've done that, and we need to record off the inputs, right? So we got the inputs here. Oops. Okay. So what we can do is input history. I think it was opponent side is equal to this buffer, right? Oops. Wait. Oh yeah. Right. So we need to index this correctly. So we need to do start frame plus I. It's going to be equal to that. This is correct, I think. I think this is right. Okay. So we've indicated that the input we received is either the next frame is the next frame at some point, and we've recorded off all the inputs from the start frame in that buffer into our local buffer up to the opponent's current frame. Great. We might want to do some logging with that later, but I'm going to move on. And now we need to actually use this latest network frame to indicate whether or not we can update this game simulation. So it's either going to be the frame, our target frame. It needs to be at least the target frame or higher. So we have this code for looping through here and see if we have the input. We don't need that anymore. So we can just get rid of this. What we need to do is see if latest network frame. Sorry, I'll actually look at that real quick. Yeah. So if this network frame, this is just Scratch. I'm just like Scratch idea, Scratchpad kind of idea thing here, brainstorming here. This is kind of the general idea. If the latest network frame is greater than here, then we need to set this to up to next frame to true. Otherwise, it's going to be false, right? We have this kind of sentinel thing here. Assuming we always update the first frame. That's what this does. Okay. So after the frame number 0, say we're at frame number 1, we need to make sure the latest network frame is okay. Oops. Okay. It actually needs to be greater than equal because this is our target frame, right? No, this is true. Sweet. That should do it. Okay, so now we indicate whether or not we update the game. But we still need to take the input from the input buffer, right, to use in the game simulation. Otherwise, we're not going to be synchronized. Because again, this whole idea of we need to apply the same inputs on both sides at the same time. to stay synchronized. So we have this to use variable, which we're not using here yet, but we don't need this anymore because we have that input history, right? So what we can do is go input history, opponent side, and then game state, frame count. And then we update the frame simulation. There's one more thing I want to do before we test this is I want to make sure that we're actually applying the input with the latency, the input delay applied. So let's just do that real quick. Okay. So this did the delay for us, but now we actually have a delay constant we can apply. So after we record our input, whoops. So what we can do is, we don't need that anymore. We say local side. I call it network input buffer. Why did I call it that? Anyway. We don't want to do this anymore. What we want to do is so we recorded it off here on the local side, and we've recorded it with a network with a delay, right? So what we want to do is actually get the input with the delay here. We could do it here to make it, yeah. So let's do it here to put these together. Okay. We don't need to apply network delay to the opponent's side because the input we received is already indicated for that frame, or is already designated for that frame. Okay, so current frame, which is our target frame, plus the input delay. In this case, it's 1. Okay, what is this complaining about? Oh, did I do something here? I'm gonna get back to that. Do we have any errors in our build? Okay, looks like everything runs. Okay, let's get some logging going and run our game simulation. Sweet. Got it. So it looks like we're ticking. If you look at it now, we can see the frame counts updating on both sides. And I can move around, and it's synchronized. So packet loss is no longer causing the issues of desynchronization. And Bob's your uncle, it works. Now, I can't prove that it's entirely synchronized right now, but it seems generally synchronized, right? Oh, looks like we got an issue here. So we did have a desynchronization, I think. If we look at the values, P1, yeah. So P1 is desynchronized on P2, but looks like P2 stays synchronized. But at least at the moment, the game isn't totally desynced for the point where we're not even updating. We can check and debug this, but I think I'm going to save that for the next stream because I just wanted to demonstrate this general principle of packet loss compensation. Is there any questions about this? I mean, with that, it's about 2 o'clock here. I know it's going to be pretty late for some of y'all, like midnight, I think, on the East Coast. But yeah, I think I'm going to leave it at that for now. We spent about a good hour and a half on this. I think makes it a stopping point. Yep. I'll give you guys a few minutes if you want to ask any questions. I know this part was probably a bit more confusing, but it's a really important aspect of synchronizing game states, or the synchronizing game clients. I might do a short stream debugging the issues here next week before I move on to. I think the next thing we need to move on to is rollbacks, actually. So that should be fun. We'll fix this bug on the next stream, and just the state synchronization. We'll fix that, and then we'll move on to rollbacks. Is anyone still actually around? Well, it's fine. I can upload this to YouTube, but yeah. Well, it's not any questions. I will probably cut the stream off. I hope you guys learned something. Yeah. I think about an hour and a half here. I'm fading from all the talking, so there you go. Oops. Well, we got a crazy amount of delay now, huh? But yeah, we'll fix these issues that popped up next time. Yeah. And we got a crash. Okay. Well, again, if there's nothing else, I think I'm going to cut it off here. And see you next time. Thanks for dropping by. And have a good night.